to get that in there, huh? I record for the other class as well, and they're on 3.3. That's why I said not 3.3. They're on chapter 3, not 3.3. 1.3. The regular algebra 3. They don't have a P. Oh, they don't have one that we don't speak of. They don't have that chapter we never speak of, right? All right, so our objective today is to talk more about functions. Yesterday we started with it, so these are the moron functions. So moron functions. We're going to identify intervals in which the function is increasing, decreasing, or it's constant. Not a big deal. Use the graphs to locate relative minima or maxima. Identify whether it's even or odd. Understand the use of piecewise functions. You guys remember piecewise functions? No. They really are in pieces. And then finally, we simplify functions. Difference of quotients. This last one I hope we really definitely get to. It's the beginnings of calculus. The beginnings of calculus. All right, so this should make sense. If you have an x value, let's say it's 2. And as I move over to the right, the next x value is 5. And the y values also increase. So let's go 2, 2 to 5, 5. What's happening, obviously, to my function? It's increasing. That's what that top part is saying. Now, if you have 1 and then the other ones are smaller, then what's happening to the function? So it's just a bunch of fancy jargon saying, you know what? If one x is bigger than the other, then it's increasing. If the other x is less than the other one, then it's decreasing. But that makes sense in our head, right? Now, if they're the same, then the function is constant at that point, right? Yes?
Yeah.
If I go from 2, 3 to 5, 3, has the function changed? No, it's just flatlined. And that's all this is saying. Okay. All right, here we go. Here's a picture. And we need to identify where it's increasing, where it's decreasing. Obviously, we can all see that it's going up from here all the way to here, correct? Yeah. So we would say it's increasing. And I'm going to go in. Is that cool with you guys?
Yeah.
And we're increasing from negative infinity all the way to where? Negative 1.
Wait. Oh, yeah.
Okay? And then we're going to decrease from negative 1 all the way to, looks like positive 1, huh?
Yeah.
Positive 1. And then it's going to start increasing again. So we're going to start increasing again from 1 to positive infinity. So there we go. We've just identified the increasings and the decreasings. What's up?
Why is there a bracket on the...
I'm not sure which one it wants. Well, are we supposed to do, if we're supposed to do brackets, or if we're supposed to do parentheses? And we'll get to that in a little bit. We'll figure it out, okay? But it's not a big deal. We're just saying from where to where. What's up? Well, brackets, it just means you're equal to that.
Yeah.
Which they're definitely equal here, right?
Yeah. You know, I do last homework and I was on the same problem for like, I don't know how long.
What did this want here? It doesn't say, huh?
It has brackets.
You have brackets on the homework?
Yeah.
Then you probably want to go with the brackets. Because it makes sense. You're going to be equal to it still. And you should have bracket here, bracket here, bracket here. That makes sense. All right, can I clear this? How do I know? Because my function actually has a value there. It's not like an open circle, right?
How do you know?
It would be. It would have an open circle in there. It would literally be like a circle, and it'd be empty. That's mean it's not part of it. You won't see it, but you'll see it because of the denominators in your functions, right? You can't have those zeros in there. That's what they would look like in a real graph that we draw. Our calculators are not smart enough. Our calculators are only tools. Still don't get it? All right, we'll get it in a little bit. Some other things we can observe while we're looking at this. We can see where our relative minimum and our relative maximum are, correct? We can see that our relative maximum is here at x equals negative 1, and it happens to be 5. No, it's not even 5.
It's
like 2 or 3 maybe?
Yeah.
We can also see our relative minimum is over here at positive 1, right?
Yeah.
Now, why do we call those relative min and relative max? Really obvious.
Because the other one's better.
Yeah, the others are go on forever. Forever.
This isn't the Sandlot.
Yes, it is. Moving on. And that's what we just said, relative minimums, relative maximums. And we just did that too, so let's move on. Even functions or odd functions. If you have a function and you change it, instead of putting an x in there, you put in the opposite of x, and then you clean it up. If, let's see here, for all the, even. So if it's even, and you put in that negative x, and everything comes back the same, like it originally was, then it's an even function, okay? So you plug in a negative x for all the other x's, you simplify it, and if you get the same function back, that means that, here it is. That means that if your original f of x function equals the same as if you put a negative in there, then it's an even function, okay? Now, if you don't, and everything changes signs, if everything changes the sign, so your positives become negatives, your negatives become positives, then you have what's called an odd function. Now, if you plug in a negative and some of them change and some of them don't, then it is neither positive or negative. Okay? What happened? Okay. Questions on that? May I move on? Odd, even. Determine. Go ahead. Figure out whether this is odd or this is even or this is neither. Give you guys a minute. Welcome to the dojo. Oh, will you write it down for me? You wrote it on your hand?
Lotus touch.
Lotus touch. Actually, I'm going to do this. What? Drinking milk. Remember back then when they had all these campaigns about milk? Yeah, better than money.
Well, like that's.
All right, sounds like we got something. Jack Quillen! The dojo has picked you. What'd you come up with? Is it even, is it odd, or is it neither? Is it neither? Okay, and I could just take a look because there's no way that I can change that to be a negative, right? Like, even if I change that multiplied by x, it doesn't have an x in there. Here, let's just do it. X to the fifth plus 1, right? And h of x is going to become a negative x. It's going to become a negative x, negative x. This is going to give me a negative x to the fifth plus 1. Now, here's what happens. Is this the original function?
No.
So it's not even,
Yeah.
right? Did all the signs change?
No.
So it's not odd. Only this one changed, but not the other. Therefore, this is neither. What's up?
So it was x to the fourth power, then it would be even?
Even.
Yeah,
Yes.
because the negative would cancel out.
Right. Exactly. Good job. Can I change this slide?
Yeah.
The question was, what if that was, it just changed. What if that was x to the fourth plus 1? Well, if I put x, negative x in there, negative, 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 negative becomes positive. None of the signs change. You get back exactly what you had. Therefore, it would be even. Okay. What did I want to say with this? Oh, they want us to graph a function where it is symmetric with respect. Well, you just gave me one. What was it? X to the fourth plus 1? There you go. That is y equals, that's a sketch of y equals x to the fourth plus 1.
And it's symmetric because it's the same like from the y-axis?
Yes. Cool?
Yeah.
Yes.
Questions? Any other of the evens would have worked. X squared plus 1, x to the 6th plus 1, or without plus 1, maybe a minus 1. Questions here?
So the plus 1 would be like where it's on the y-axis, right?
It's a shift. It's a vertical shift. What's up? No. In this case, it does because it was only 2 items. But you really have to be careful when you have all the others. Like in this case, it's just this, right? So as long as I choose an even, the negatives will always become positives at the end. Does that make sense? But if I had something like when we did, like let's say it was even x to the 4th plus 3. Let's do this. Let's go minus 3x to the 3rd plus 2x. I don't know, minus 1. I'm just making this one up. I don't know if it's going to work or not, okay? And if I were to change all the signs, so this would be negative x to the 4th, negative 3 times negative x to the 3rd, plus 2 times negative x minus 1, okay? This is my original. Now this is still going to be, I'll change colors here. This would still stay x to the 4th, right? This would give me 3 negatives, and another negative would make this positive. 3x to the 3rd, right? Negative 2x minus 1. Now, I see that these are the same. These changed. These changed. And these are the same.
So it's a neither.
So this is neither. Either none of them change, or all of them change.
But if it's in the middle,
Two sets change.
Well, the rule is, it's either they all change, or none of them change.
So they'll change.
If they all change, it's odd. If none of them change, it's even. And if you get some that change and some that don't, then it's neither of those. Okay?
then it's a moral.
Graphing with respect to the origin, where it's an odd function, and that's going to be your cube guy.
Is that it?
I want to say that's your cube one.
It is a cube one.
Yes. Okay. So usually the third degrees, fifth degree, 7th degree, they all look the same. They're just a little bit flatter in the middle. Right, Ernesto Cipriano? Yeah. All right. I'm gonna move on. Someone's reading hard back there. Piecewise functions. Piecewise functions are exactly that. What they're doing with a piecewise function, they're giving you one equation that has multiple parts to it. They're saying, hey, you know what? If x is, I don't know, I'm going to make this up. Let's say x was less than 1. If x is less than 1, I want you to use the function x plus 1. Okay? So I'm showing you how a piece mate is done. It's a function that is actually many functions together. Okay? So, what we're saying here is that if x happens to be less than 1, I'm going to use this function x plus 1. If x is greater than or equal to 1, but can I do less than? But less than, I don't know, pick something. 5? 5? I'll go with x squared, okay? And maybe if x happens to be bigger than 5, then I want to do, I don't know, we'll do another linear? Yeah. Let's go 2x plus 3, okay? So, this is a piecewise. Because different pieces of it will look like different functions. Does that make sense?
Mm-hmm.
So when I pick a value for x, because that's what we do, don't we? I don't know. Tara, it's your birthday. Pick something. Go crazy.
I was looking.
Pick an x. Good job. Thanks. So right now we're trying to figure out what the function is when x is 1, right? Well, let me figure out my criteria here. Is 1 less than 1?
No.
No. Is it between 1 but less than 5?
Or greater, yeah.
Yeah, it's in here, right? That means that when x is 1, I need to use this function for x squared. So when x is 1, then y is 1. Okay? And here's what's really going to happen. From all the values from 1, 2, 3, 4, 5, it's going to take on the shape of that parabolic thing going, like that, kind of like a parabola. And over here, once we get past 5, it's going to take on this shape, which means it'll probably be down here somewhere, wouldn't it? Yeah? Am I tripping? No, it should go up. It should go up. So what would it be? If I pick 6, if x is 6, it'd be 15?
Yeah.
Holy smokes. Let's say 15 was, I'll use red. Let's say 15 was up here. And that means it would take on a positive slope, right? And then that would be the end of it. It will go on forever in that direction like that. This is definitely terminal. Actually, they should be on top of each other, shouldn't they? This should be an open circle.
What if it was like 5.2?
Hold on, let me move this fixes. It should be there. It should fit 5. It should just pick
5.5.
up. Then it would be in here somewhere. There, let's do this. Let me do this. What was our first function, people? X plus 1. My other one was x squared.
Yeah.
X squared. Instead of me trying to draw it, I'm going to show you what we're looking for, okay? And then the third part? 2x. I forget how to use a calculator sometimes. So there's my three pieces that's defined. Now I want you to watch this. Here's going to be one function. Our quadratic should come in second. And then we should get our, hopefully we can see the last piece. There it is. Let me change my window. I want more of the top one. Window, Y max, let's go to 20.
It's just 2. It's just 2.
Let's change that scale to 2. That way it looks the same, but it's a little bit higher. Let's see here. Okay, so here's that first line. Here's the quadratic. And here comes the other line. Okay, so do you guys see all three functions there? Yeah. Some of these parts don't matter. Whenever I am less than 1, where's 1 at? Green. So less than 1, do you see that? This is what the graph will look like. You see the green part?
Yeah.
And when it's greater than 1, it should look like this piece. All the way up to how much?
5.
Holy crap, that's way up there. That's not going to work. Let's pretend that this was 5, okay?
Well, aren't you going by 2s?
On the y's, not on the x's. So then my function will look like that. And then finally, if it was greater than 5, I would jump over to this graph. So let's see if I can. I'm not going to be able to move it, am I? Nope. Can I do, I know what I can do. Yeah. Clear. 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 Oh, can you see it?
Yeah.
There's my graph. That's what my graph would look like. It's kind of gross, but the first part should be linear because it was a line. The middle part should be quadratic, and that doesn't look quadratic very much, but it is. And then the last part should be linear. And that's what they mean by piecewise. Different parts will behave differently. Okay?
So that's what it would look like.
This one's a really gross example. I made it. Let's see what we have here, okay?
I mean,
Yeah, and there's a way to do it on your calculator where it actually just shows you the pieces you want. I don't remember how to do it at all, like, for the life of me. But we'll figure it out and I'll show you guys, okay? Now this one's only, thank you. This piecewise is only made up of how many functions? 2. It's really nice because, for the most part, what's it equal to? 20. Guys, there's 20. So from 0 to 60, I don't even need all this, do I? So let's pretend, here's what we got, quadrant 1. And here is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay? So 1, 2, 3, 4, 5, 6. And here is 5, 10, 15, 20. So there's my scale, and these are going by 10s, right? All right, so when t, and this is t here, is from 0 to 60, 2, 3, 4, 5, 6, 6. It's going to look like that. Because it's always equal to 20, right?
yeah.
And then once I get to the other part, which is greater than, it should look like this line. What is this line? Holy junk, it's going to be gross, isn't it?
It looks like it.
Let's pretend that this is the line. Okay? We see the two pieces?
Yeah.
Okay, now one of these should be open circle. Where?
That one.
Exactly. And that will go forever that way. Okay? You should never have two solid circles on top of each other. Because then, so confused? Why?
How do you know when it's a circle? How do you not know?
Not equal to.
Is that equal to?
Equal to? Solid. Not equal to? Open.
And that's what the brackets mean.
Yeah.
Okay, okay.
I thought we talked about that. I guess we didn't. This, All notations for the same thing. Notations for the same thing. Okay? Guys, that's it. That's my slide.
That's it?
Yeah.